An application of all this solving of equation stuff that you've been learning is to use them to solve formulas. You see formulas in everyday life, formulas that convert temperatures or formulas that tell you how much money you're going to make. So let's start by defining what a formula is. It's just simply defined as a mathematical relationship or rule used or expressed, I should say, with symbols. So we have a lot of symbols, variables within our formula. So let's write this down. And there you have it. So before we get to the formulas, we're going to start transforming equations, which can be considered a formula in this sense because you have a lot of mathematical symbols in there. You have an x and a y. And in this case, we're being asked to solve this equation for x. And so you need to get used to manipulating an equation that has lots of variables in it to get a specific variable isolated. So in this case, we need that x alone. So keep your eye on that x, and you need to ignore that there's a y in there, because remember, y is just a number. We don't know what it is right now. So if I wanted to solve this equation for x, I have two operations acting on it. I have addition and I have multiplication. And you've learned the rule, you must undo the added or subtracted term first. So all you would do in this case is subtract 7 from both sides. And then always rewrite what you're left over. The expression is. So that's what's on the right, and then on your left there's nothing you can do with the y and then the minus 7, so you just write it down, and you have to get comfortable with seeing that like that. Again, keep your eye on the prize, and that is to isolate x. Well, the only problem now is that 5 is being multiplied by it, so we are going to undo that multiplication with division. This entire side is going to get divided by 5. And you have done what you've been asked to do. You were asked to solve for x, and there you did it. So your final expression, and I switched my x side. I didn't have to, but I did. So we'll leave it. And then you're just left with this. So you have solved this equation for x. Let's try another example. I'll have to get rid of this here. Okay. In this case, we are asked to solve this equation for x again. And so let's find our x. It's right here. And I have two operations acting on that x. One is minus 8 and one is times 3. So again, we always undo the added or subtracted term first. We do not care about this side right now. It's all about solving this equation for x. So we'll add 8 to both sides, and I'll put it under its like term, leaving you with 3x on the right, and then y, and then you can actually simplify this right here. Negative 4 plus 8 is a positive 4. Alright, and now your job, one more step, is to divide by 3 to undo that multiplication. Again, this entire side gets divided by 3. You have done what the problem asked you to do, and that was solve this equation for x. Alright. Alright, let's look at your guided practice for a minute here. It is still the same process as we did above. We're being asked, though, this time to solve each equation for y. So you can see your y is here, and now this might be new to you because we didn't have an example like this, but this 2x, you need to get rid of that whole thing. So we need to undo this addition of 2x, and you need to get very used to doing that. So I will subtract 2x from both sides. Remember, that's just a number. If we knew that x was 5, we would know that this number here is 10, and subtracting 10 is no big deal. But we don't know what that number is at this point. So these cancel, leaving you with y on the left side, and then here you cannot do anything to combine those because they are not like terms. So that is the final result. You have solved for y, so you've done your job. Alright, now I'm going to have you do letter B totally by yourself, so pause the video now. Alright, so let's talk about this a little bit. We were solving for y, so we needed to subtract this term from both sides. There's no combining like terms there, you just leave it written. And then I divided by 2, leaving this as your final answer. But now some of you out there might notice that 8 and 2 and 4 all have a common factor, so perhaps you simplified it to this answer. I would take either one right now. The thing we're learning in this video is how to solve a formula or an equation, and that was done in this situation. But if you see that you can reduce that fraction, that's a great answer too. Alright, we're going to step it up and do some harder equations, ones that don't have any numbers in them, perhaps just all letters like this one over here. So in order to teach you that these are not a big deal and they're not something new, I'm going to go to an equation that you're totally capable of doing. So notice over here I have 2x minus 4 equals 10, and I'm asking you to solve for x. Well, I purposely wrote a term where you had multiplication going on, minus a number equals the letter j. So they're exactly the same form here. Here, if I ask you to solve for x, we're going to walk through that, and you know how to do this. So you know that I would have to add 4 to both sides, and I get 14 here and a 2x there, and then to isolate my x I divide by 2, leaving you with x equals 7. So over on the right side, nothing is new there either. I need to solve for c, okay, and I have a term that's being added and subtracted, so I'm going to undo that one first. So I'm going to end up adding k to both sides. So here I have j plus k, and on the other side I'm left with a times c. So again, if you look at these two sides, they're totally identical. One's just written with letters, and I can't combine these where I could have over here. Now your final step is to solve for c. A is in the way, so you're going to divide both sides by a, and that entire side gets divided. So you are left with a final answer of c equals j plus k over a. And you have done what you were asked to do, and you solved for c. Let's look at our next pair of examples. I have 4 minus 3x equals 13, and over here I have an equivalent equation written with all variables, no letters whatsoever. Again, the rules stay the same. It doesn't matter if we're dealing with letters or numbers. We just need to use inverse operations to get our x isolated in this case and our f isolated in that case. So the first thing we'll do is undo this added and subtracted term. Now this 4 is positive, and so to remove it I'm going to subtract 4 from both sides, leaving me with negative 3x equals 9. Now to complete my process I need to divide by a negative 3, canceling those, and x equals negative 3. Let's look at the equivalent process next door here. So if I'm being asked to solve for f, that's right here, and I have a term being added or subtracted, and that's the m. I will undo the m by subtracting it because it's already positive from both sides, leaving me with negative w times f equaling d minus m. Again, I am isolating f, and so that negative w is in the way. I need to undo it. So I will divide by a negative w both sides. This cancels, and you are left with f equals d minus m over a negative w. Just follow the rules of algebra and you'll be okay. Alright, here's some guided practice problems. Definitely want you guys to try these. These are formulas and ones that we've dealt with before. You've seen d equals rt. This one is the circumference formula for a circle, so go ahead, pause the video. Right, and here are those answers. This one was pretty straightforward. We were solving for r, so you needed to divide both sides by t, leaving you this equation. Down here, the overall idea was to get r alone, so this 2 and that pi both need to be divided at some point. You can do it all at once, but I did it separately just to show you. So I divided by 2, and then in this case, when you're ready to get rid of pi, it's going to go downstairs in the denominator on the other side because it is a division, leaving you with this as a final answer. These will get easier the more you do.